Alright, in this video we're going to go over vector 5, each problem one by one. Number 1, use vector methods to find the angle the diagonal of a cube makes with one of its edges. Okay, so let's draw coordinate axes, and then here's a cube. Now, since you're finding the angle, you're going to use the dot product, right? Because that's the tool. So if this is a cube, in fact, why don't we call this point up here 1, 1, 1? Let's just make each edge of the cube 1. Then what is the diagonal? The diagonal goes from one corner to the opposite corner like that. So we have to find the angle that this diagonal makes with one of the edges. Now, which edge do you want to use? The one on the x, the one on the y, or the one on the z? It doesn't matter. Pick one. Okay, why don't we do the one on the x right here? So this point here would be 1, 0, 0. So how do you find the angle formed by two vectors? You use the dot product thingy, right? So first step, componentize the vectors. So again, this is the origin. So if you go head minus tail, you get 1, 0, 0. And then this vector here, if you go head minus tail, you get 1, 1, 1. How do you find the angle between two vectors? The cosine of this angle is equal to the dot product of these two vectors. So that's going to be 1 plus 0 plus 0, all over the length of this vector, which is 1. And then the length of this vector is the square root of 1 squared plus 1 squared plus 1 squared, which is 3. So that's what? 1 over root 3. So the angle is cosine inverse 1 over root 3. Bam! Finished. So again, anytime it says find an angle measurement, use the dot product. Number 2, write the equation of the sphere with center 2, 3, 5 that is tangent to the plane 3x plus 4y plus 5z equal 3. Okay, so basically this is what you got. You got a sphere, we know the center, 2, 3, 5, and it is tangent to the plane. This is a plane now. 3x plus 4y plus 5z minus 3 equals 0. Now, what do you need to write an equation of a sphere? You need the center, which is given, and then you need to figure out the radius. Well, when you draw the radius to the point of tangency makes a right angle, is there a way I can figure out this radius right there? Yeah, isn't that simply the distance between this point and that plane? Do we know how to find the distance between a point and a plane? Yes, we use the formula. So absolute value, 3 times 2 plus 4 times 3 plus 5 times 5 minus 3 all over the square root of a squared plus b squared plus c squared. So what is that? 9 plus 16 plus 25. So what does that come out to? 6 plus 12 plus 25 minus 3. What is that? 40 over root 55 root 2. So 5 goes into 40 8 times. So 8 over root 2. What is that? 4 root 2? That's the radius. So therefore, the equation of this sphere is x minus 2 squared plus y minus 3 squared plus z minus 5 squared equal to the radius squared, which is 32. Child's play. Okay, number 4. No, we're doing number 3, fool. Write the equation of the set of points that are equidistant from the point 0, 0, 1 and the plane z equal negative 1. So this is kind of like what we did when we did conic sections, yeah? I'm going to describe a set of points. You have to write the equation, except this is going to be in 3 dimensions. Okay, so here is the point 0, 0, 1. Now the plane z equals negative 1 is like 1 unit below the xy plane. So it's like 1 floor below the lobby right there. Okay, so if this is a representative point, x, comma, y, comma, z, right? Then this distance and that distance, so this is a point on the plane z equal negative 1. These two distances must be equal. Well, how do you find this distance? You use the distance formula. x minus 0 squared plus y minus 0 squared plus z minus 1 squared. And that has to equal to this distance right there. And again, if this is 1 and this is 4, how do I know that's 3? If it's like vertical. Top minus bottom. So, this point right here, since this is like parallel to the z-axis right here, what is the z-coordinate over here? Z. What's the z-coordinate down there? -1, right? In fact, what would be the point right below this? Wouldn't it be x comma y comma -1? Since it's on the plane z equal -1. Anyway, so how far is it from z to -1? Top minus bottom, z plus 1. And there you go. That's the equation of whatever this is. But you could have probably guessed what it is, right? What's the set of points that are equidistant from a point and a plane? Well, it's going to be a paraboloid, right? It's the three-dimensional version of a parabola. And then all you have to do is, let's just do it. Multiply out everything, square both sides. Z squareds cancel out, 1's cancel out. X squared plus y squared equals 4z. That's what an equation of a paraboloid looks like. So the paraboloid looks kind of like this, yeah? Paraboloid, parabolic dish. Number 4, find a unit vector that is perpendicular to this plane. Now we already had a problem before, the unit vector. A unit vector is a vector that has a length of 1. Okay. Now remember, if this is the plane, here I'll write it, 2x plus 2y plus z equals 7. That's not 7, fool. Like that. To work with planes, what you want to do is you want to work with its perpendicular vector. We call that n for normal vector. This vector. Well, if this is the equation of the plane, can you tell me what this normal vector is? Isn't it 2, 2, 1? You look at the coefficients. Yeah. So it says find a unit vector that is perpendicular to this plane. So this vector is perpendicular to the plane, but it says find the unit vector. Well, what is the length of this vector right here? How do you find the length of the three-dimensional vector? It's the square root of this squared plus this squared plus this squared. 4 plus 4 plus 1, which is 3. So if you have a vector that has a length of 3, what can you do to make it have a length of 1? Multiply it by 1/3. So if I take this vector here and multiply it by 1/3, what are you going to get? 2/3 times 2, not times, 1 there. That's it. Now that's just one answer, because couldn't you also have had this answer? -2/3, -2/3, -1/3. Yeah, because both of these are perpendicular, except this one is the opposite of it. It's pointing in the opposite direction. So that's why, yeah, you can have either of two answers. Next, number 5. I'm pretty sure this problem's on the test. So you have 3 points in space. A, 3, 1, 4. Hey, look at these numbers. This is like the digits of pi, 3.14159265. Am I the only one seeing that? Probably. Okay, there you go. Use vector methods to find the measurement of angle ABC, this angle right there. Let's call it theta. Now again, we're finding an angle, we're going to use the dot product. So first thing, componentize. So to componentize vector BA, now remember BA and BC are forming that angle right there. So head minus tail, what is that? 2, -4, -5. This vector in component form, head minus tail, 1, 1, -4. Okay, so let's do the dot product thingy. Cosine of the angle is equal to the dot product of these two vectors. So that's going to be 2 times 2 minus 4 plus 20, all over the length of this vector, which is the square root of this squared plus this squared plus this squared. Was that root 18? 3 root 2? And then the length of that vector, which is the square root of that squared plus that squared plus that squared. So 4 plus 16 plus 25. Root 45. Isn't that 3 root 5? Okay, so what do we got there? 18 over 9 root 10. Yikes. Of course, 9 goes into 18 two times. So the angle is cosine inverse 2 over root 10. Yeah, or should we simplify it to 2 root 10 over 10, because 2 can go into 10 5 times. Root 10 over 5. Whatever, Danny. Okay, and then find the area of triangle ABC. Now remember, there's two ways of doing it. The way we did it the first time is just go 1/2 AB sine C, so you got to find the sine of this, but that's easy, draw the triangle. Or we can go half the length of the cross product. Now you might be saying, well, why do I need to find the cross product? Well, we're going to have to do it anyway, right? Because that's what we have to do for part C, because we got to write the equation of the plane containing it. So why don't we do it that way, because I think that way is faster. So, part B, find the area of the triangle. So find two vectors that form the two sides right here. And we already did it. This is vector BA and this is vector BC. Let's compute the cross product. So you make a determinant, IJK. Now we don't care if the vector is pointing that way or that way. So it doesn't matter which order you put the components in. So how about 1, 1, -4, 2, -4, -5. So I like to go across the first row, so it's going to be I times -5 minus 16, that's -21, minus j times -5 plus 8, which is 3, plus k times -4 minus 2, which is -6. And for those of you who don't like the IJK notation, then do this, -21, -3, -6. This is the cross product. This vector is perpendicular to the plane containing this triangle right here. Okay, let's answer the question now. What is the area of this triangle? Well, it's half the length of the cross product. Well, here's the cross product. How do you find the length of it? The square root of this squared, 441, plus this squared, 9, plus this squared, 36. That's the length of the cross product divided by 2. Boom, that's the area of the triangle. Now, can we simplify that? What is that? Root 486 all over 2. Can that be simplified some more? You know what? I will let you do the simplifying. Anyway, that's the answer. You just have to simplify it. I believe you can simplify that. And then now, write the equation of the plane for part C. Well, to write an equation of a plane, you need a perpendicular vector and a point. Now, we already have 3 points. We just need a perpendicular vector, but we just found it, the cross product. The cross product is perpendicular to the plane containing these two vectors right here. So here's the cross product. Therefore, the equation of the plane is -21x minus 3y minus 6z plus d equals 0. And how do you figure out what d is? You plug in one of these 3 points. Which one looks the nicest? Probably A, yeah? So if I plug in A, 3, 1, 4, you get. So if I plug in 3, 1, 4, you get -63 minus 3 minus 24 plus d equals 0. Therefore, d is equal to 90. So therefore, the equation of the plane is -21x minus 3y minus 6z plus 90 equals 0. But you can clearly see you can divide through by 3. In fact, why don't we divide by -3 so that the first term will be positive? So 7x plus y plus 2z minus 30 equals 0. That's the equation of the plane. Okay, next, number 6. The angle formed by A and B when placed tail to tail is 120 degrees. Okay? The length of vector A, so this is 120 degrees, is 5, and the length of vector B is 3. Find the length of vector A minus B. Now there's 2 ways of doing this problem. First of all, if this is A, vector A, and this is vector B, where would A minus B be? Okay, I'll give you a hint. It's a vector that goes from here to here. Which direction though? If I want this to be vector A minus vector B, which direction am I going to, which direction does it point? Does it point this way or does it point that way? 50% chance. Again, you have to know how vectors work in addition. This plus this equals that. Okay, let's say you don't know. Why don't we call this box right here? So, if I make the vector point this way, then what plus what equals what? B plus box equals A. Therefore, what is the box equal to? A minus B. In. That's it, right there. So, if I make the vector point this way, then this vector is A minus B. If you make it point the other way, it will be B minus A. Now it says find the length of vector A minus B, right? Let me look again. Yes, it does. Well, if you know two sides and the included angle, how do you find this third side over there, opposite that angle? The law of cosines. Why don't we call this x? X squared equals 3 squared plus 5 squared minus 2, 3, 5 cosine of 120 degrees. And of course we know cosine of 120 degrees is negative half. So what do we got? 9 plus 25, 34, plus 15, which is 49. Therefore x is 7. Oh, Mr. Park, every time we have a law of cosine problems, the answer is 7. Unless it's not. Okay, so that's one way of doing the problem. Another way is to componentize the vectors. Because some of you are just not going to see that this third side of the triangle is A minus B. Well, not to worry. Just componentize and you don't even have to think. Okay, so what you want to do then is put these vectors in the coordinate axes. So, if I were doing this problem, I would put the tail of the two vectors at the origin, 0, 0. And I would put vector A here, and it's 5 units long, so therefore this would be 5, 0. And then B would be over here. Remember, it makes a 120 degree angle, and the length of vector B is 3. So, is there a way I can figure out the coordinates of this point right there? Yeah, you can either do polar or just figure it out. Look, if this is a 120, that's a 60, that's a 3, that's a 3 halves, and that's a 3 root 3 over 2, right? 30, 60, 90 triangle. Therefore, the coordinates of this point, negative 3 halves, 3 root 3 over 2. So, vector O, which one is A? This one, A, componentizing it, right, is what? Head minus tail, 5, 0. Vector OB in component form, if you go head minus tail, going to be negative 3 halves, 3 root 3 over 2. And then now, once you componentize the two vectors, just do what it says. It says, what number are we doing? Oh, vector A. Oh, this is vector A. Darn it. I put OA. This is vector B, B. Anyway, whatever. Just do what it says to do. A minus B, and then find the length of it. Well, how do you subtract two vectors if they're in component form? You just subtract the components. This minus this, 13 halves. This minus this, negative 3 root 3 over 2. Now, how do you find the length of a two-dimensional vector? It's the square root of this squared, 169 over 4, plus this squared, 27 over 4. So that comes out to root 196 over 4, which is 14 over 2, 7. Now, I don't really care which way you do the problem. I guess this way is more straightforward, but then, like I said, this one, you have to know that the third side of the triangle is A minus B. It's the difference of the two vectors. You guys in physics probably know that already. Number 7, vector V in component form is 3, negative 3 root 2, negative 3. Find the angle that this vector makes with the positive z-axis when you put the tail at the origin. Okay, let's draw a picture. Now, this is not an accurate picture because, of course, the y and the z components are negative, but if we put the tail at the origin, you're going to get some vector there. I want to know what angle it makes with the positive z-axis right here. Let's call it theta. And again, find angle. I'm going to do dot product. Okay, can you think of a vector that points in the positive z direction? Yeah, how about 1, 0, oh, that's not right. How about 0, 0, 1? How about 0, 0, 2? How about 0, 0, 3? Yeah, any of those, 0, 0, 10. Just pick one and go with it. So, if you know the components of the two vectors, how do you find the angle between them? You do the dot product. Cosine theta equals the dot product of the two vectors, so that's 0 plus 0 minus 3, all over the length of this vector, which is 1, and then the length of this vector is the square root of this squared plus this squared plus this squared. What is that? 9 plus 18 plus 9, 36. So that's negative 3 over 6, negative half. Therefore, that angle is 120 degrees. Or if you rather put radians, 2 pi over 3. I don't care. I'll accept either. Yeah, that one came out nice. We didn't have to use cosine inverse. Okay, number 8. Aha! Now remember what I told you guys in class. When you're converting from one coordinate system to the other, draw the box. Okay, I'll tell you right now, this problem is on the test. Draw the box and nobody will get hurt. Alright, so we have rectangular coordinates. 3, now, it really doesn't matter what it looks like, just draw a box. I'm going to make it in the first octant so that it's easy for you. Okay, so if this is the point 3, 3, root 6, doesn't that mean this is 3, and this is root 6? Yeah, so knowing the dimensions of the box, can you find the cylindrical coordinates? Now, what are cylindrical coordinates? R, theta, z. Okay, so this z coordinate is the same thing as the z coordinate in the rectangular coordinate system, so that's root 6. That's z. Now, all you have to do is get r theta. These are polar coordinates. So, if the x and the y coordinates are 3 and 3, r is this distance right there, right? Now, if you have a hard time looking at that picture, draw this then. What if you're just looking straight on to the xy plane? If this is 3 and this is 3, how far from origin are you? 3 root 2, right? So that's r. And then, what's this angle there? 45 degrees or pi over 4, I don't care, radians, degrees. There you go. So this is 3 root 2, and that angle right there is 45 degrees. I'll put degrees over there, radians there. See, again, draw the box, so easy. Now, convert it to spherical coordinates. Now, what the heck are spherical coordinates? Rho, theta, phi. Now, this theta is exactly the same as this theta. It's this angle right there, so 45 degrees, or pi over 4. Now, what is rho? Rho is how far this point is from the origin. Well, can I figure that out? Well, isn't this a right triangle right here? Look, there's a right angle there. If you know two sides of the right triangle, and again, if you need to draw another triangle like this, if this is 3 root 2 and this is root 6, can I figure out the hypotenuse? I'll call it rho. Yeah, use the Pythagorean theorem. So rho squared is equal to 3 root 2 squared plus root 6 squared. That's 24. So rho is 2 root 6. And then phi. What is phi? Phi is the angle that this segment here makes with the positive z-axis. This is phi. Now, how the heck do I figure that out? Well, if this is phi right here, then if you look at this right triangle, isn't that phi as well? Here, maybe if you draw this in the rectangular box, you can see it better. Oh, so isn't that just, oh, that's phi full, right there, phi? Yeah, so what's that angle? That's a right triangle. So there's lots of ways of labeling that angle. So we just go tan inverse, opposite over adjacent. So what is 3 root 2 over root 6? Can we simplify that? Root 2 goes into root 6, root 3 times. 3 over root 3 is simply root 3. Tan inverse root 3. We can simplify that to 60 degrees. There you go. So how did I do this problem that you're going to do on the test? Draw the box. Alrighty then. Okay, what's next? Well, I forget what number. Oh, we're at number 9. Okay, number 9 is just an exercise in algebra. Vector A is components 2, 3, 1. Vector B, componentized, is 3, negative 1, 2. Vector C in component form, 1, 1, negative 3. Find vector D. So I don't know what vector D is. Shall we call it A, B, C then? The components. So that the dot product of A and D is 11. Now, here's A and here's D. How do you find the dot product? You multiply the X components, you multiply the Y components, you multiply the Z components, and it says that you get 11. And then it says the dot product of B and D is 8. So here's B and D. How do you find the dot product? You multiply the X components, and then the Y components, and then the Z components, and that's got to equal, I forget the number already, 8. And then finally, the dot product of C and D is -3. So the dot product of these two vectors, multiply the X components, the Y components, the Z components, that's got to equal, I forgot the number already, -3. There you go. 3 equations, 3 variables, have fun. You guys should be experts at this already. Okay, I'm not going to do that one for you. And then, hey, we're almost finished. Number 10. Write the equation of the plane. Again, how do I write the equation of a plane? You need a point and a perpendicular vector. That is tangent to the sphere. Okay, so here's a sphere. X squared plus Y squared plus Z squared equals 49. That means the center of the sphere is 0, 0, 0, and the radius is 7. Okay? At the point 2, 3, 6. So write the equation of this plane right there. This is 3-dimensional here. Plane. The plane, boss. Well, what do I need? I need a point. Well, this is a point on the plane. Not this one now, this one. And then I need a perpendicular vector. Do I see a vector perpendicular to this plane? I see 2. This one, because remember, you draw the radius to the point of tangency, right? So you can make the vector go this way or that way. I would make it go that way. You know why? Because when you go head minus tail, you get positive numbers. So here's a vector perpendicular to the plane, 2, 3, 6. So since this vector is perpendicular to the plane, what's the equation of this plane? 2x plus 3y plus 6z plus d equals 0. And how do I figure out what d is? You plug in a point that's on the plane, which is 2, 3, 6. So if I plug in 2, 3, 6, you get 4 plus 9 plus 36 plus d equals 0. Therefore, d is equal to -49. So the equation of the plane is 2x plus 3y plus 6z minus 49 equals 0. Bam! Number 11. If vector A, okay, come on. Come on. Okay, we only got 10 more minutes here before the next class. Vector A is k, 1, 2 in component form. B, you just have to follow directions on this problem. Find the value of k, so 2 times vector A plus B and A minus 2B are perpendicular. Well, how do you tell if two vectors are perpendicular? Their dot product is 0. So the first thing you got to do is componentize these two vectors. Let's draw it on separate lines, A minus 2B. Okay, how do you componentize this one? Multiply all the components of A by 2 and then add it to B. So that would be 2k plus 1, multiplied by 2 and add, multiply by 2 and add, so that's k plus 4. Did I do that correctly? Of course, I'm the teacher. Now what about A minus 2B? So this minus 2 that, k minus 2. This minus 2 that, -3. This minus 2 that, what did I just say? This minus 2 that, 2 minus 2k. Now, if these two vectors are going to be perpendicular, the dot product is 0. So this times this, so you multiply the x components, you multiply the y components, you multiply the z components, and they got to equal 0. And you can see right there, you just got to grind down some algebra. And what a surprise, it's a quadratic equation. There may be more than one answer. In fact, if I look at the answer, hey, I only got one answer. Boo! Yeah, that's because, look right here, 2k squared, -2k squared. The k squareds cancel out. I'm pretty sure I could make a problem. Whoa, I just thought of something. Yeah, might involve synthetic division. Number 12. two vectors of lengths 8 and 10 form an angle of 2 arctan. Oh, I can tell you what the problem is already. So this vector has a length of 8, this vector has a length of 10, and this angle is 2 arctan 1/3. Find the dot product. Now, what's the definition of the dot product? It's the length of the first vector times the length of the second vector times the cosine of this angle. So what you need to know is double angle identities. Okay? So we know 8 times 10 is 80, but how do you find the cosine of 2 theta? You got to use identity. Now my favorite is cosine squared theta minus sine squared theta. And how do I get theta, which is this? You draw the triangle. Arctan 1/3 is opposite of our adjacent, and then you Pythagorize. So what is cosine theta? Adjacent over hypotenuse squared minus sine theta is opposite over hypotenuse squared, and then you multiply it by 80. I think you guys can finish that. And then B says find the magnitude of the cross product. Well, what's the definition of the magnitude of the cross product? The length of the first vector times the length of the second vector times the sine of the angle. And again, sine of 2 theta, we're going to have to use double angle identity. 2 sine theta, cosine theta. Draw the triangle, which I did. So 2 sine theta, looking at the triangle, is 1 over root 10. Cosine theta is 3 over root 10. And then you got to multiply this by 80. I will leave the computation to you. So how would I kick this up a notch? Well, instead of 2, put it 1/2. Then you got to use half angle identity. Or put a 3, and then you got to do triple angle. Wipe out. I wouldn't go more than triple, would I? And finally, number 13. Okay, so here's a picture. So these two vectors lie in the xy plane here. So you got vector A looks like this. Vector B looks like that. And then I tell you that this is a 120-degree angle. The length of vector A is 3. Yeah, just do this. The length of vector B is 4. Find A cross B. Now remember, the cross product is a vector. So you have to give not only magnitude, but you also have to tell me the direction. See, this is how I test to see if you know the right-hand rule. Okay, so first let's find the length. How do you find the length of the cross product? The length of the, what are we doing, A cross B or B cross A? We're doing A cross B. It's important which one comes first now. So the length of A cross B would be the length of the A, which is 3, times the length of B, which is 4, times the sine of the angle, which is 120 degrees. But I know what that is. That's root 3 over 2. So what is that? 6 root 3? Now that's just the length of the cross product. So if this problem's on the test, you only told me the length. That's only half the problem. Now you got to tell me the direction. So what's the direction? The direction of the cross product is perpendicular to the plane containing these two vectors. Now, if the xy plane is in the plane of the chalkboard, then perpendicular to that would be either pointing that way to diamond head or that way to opposite diamond head. So how do you figure out which one it is? You take out your right hand, and since A comes first, what's the shortest way to go from A to B? Clockwise. So curl your fingers that way. Which way does your thumb point? It points that direction. So if you're drawing a picture, it would look like that. So that's the direction. Now, so one way to do it is you can state the magnitude, you can state the direction, you can say it's pointing in the negative z direction, right? Because xy, the positive z-axis comes out this way. So you can actually just write it. The length of the vector is 6 root 3, and it points in the negative z direction. Or how about just in component form? 0, 0, negative 6 root 3. Right? See, when you put a vector in component form, it tells you everything about the vector. So I don't care. Just tell me both or componentize. I'll take either. All right. So the reason why I did this video is because we're not going to have time to do it in class. This is how we do it in PC now. So you guys better get ready for this. This video ends in 5, 4,